All right, so while we are waiting for 6B and 6, the other classes to come back, and you'll receive a file in chat box. Do you see it? So click it, and we start from this question. I would like to show you this one. That should be this one. It is Ionic Bond. Okay, start from this. So what is that? It's about the confusing terms or concepts found in DSE chemistry. Now, for Chem 1 students, we have covered something like this, but toxic, harmful, I try to leave it later, but not today, because I've just asked you some related concept before. So here comes more challenging part today. We would mainly focus on Micro World 1 and Micro World 2. Now, if we can manage, we can go to metal. I don't know whether or not we can finish Micro World 1 and Micro World 2 in this in this 1 hour lesson. Let's see. Now, please, for those students who just come in, you check your chat box, and I just talk about this one. Yeah.
新嚟嗰啲咧，未必會見到嘅。
No, I need to resend again.
Yeah.
咁麻煩㗎。I do it again. The file. I send it again. Do you find the file? Okay, for most of you, you should have got a file, right? You talk about the some hard terms to explain, right? And start from this one first. Okay, definition of ionic bond. Okay, and we will continue. I don't think we can finish them all within the hour. We just focus on some. Now we start from this. Okay. So for the meantime, I check your attendance first. 陳景熙、蔡總常、Are you here, 蔡總常? Not here.
He's here.
Yeah.
佢喺 chat box 度講 hi.
I can't find him. Yeah.
He's not using the convention of naming.
So龐家豪、文俊豪、陳浩熙 here. 張家榮 Are you here? No. Slept again. Slept for long. 何展鵬 here. 林家齊、麥耀南。
早晨。
潘樂之、邵俊熙
喺度。
黃俊熙
喺度。
鄭葵威、陳志軒 Where are you, 陳志軒唔見咗。陳龍王
喺度。
好，張家榮同埋陳志軒 not here 係咪？ 再問多次啊，張家榮、陳子軒 not here. Okay, so we would come to this one. This file. Okay. Now, I just sent you a document. All of you should have received it, and we talk about confusing terms concept in DSE. So for Chem students, we come to nearly the second page, the end of second page, and for Chem 2 students, I do think it's also worth mentioning those misconceptions or maybe some of the confused items that you may find. Okay, so now this time I shall call upon all of you to try to speak up, no matter in what language. Of course, no foul language, please. To talk about those items and try to make a clear mind of what is that. 嚟啦 Ionic bond. Ionic bond is formed when more electrons that are transferred from one atom to another. I copy in from the textbook. Okay, so if you are just to use this item to write into your DSE paper, it's called no marks. Do you know why?
Because this is not an ionic bond. The ionic bond would be actually the strong non-directional electrostatic attraction force between a positive ion and a negative ion.
Now, some key terms, I just heard of some key terms, just like electrostatic force, while the nature of it, we call that is non-directional. Between what? Between
a positive ion and a negative ion.
Yep, piece between maybe it's too cold and my handwriting is much affected, between ions of opposite charge. Okay, positive and negative. So remember, whenever you talk about the bond, you have to mention is a type of electrostatic attraction. Okay, between what? Between something somewhat positive and negative. I've just mentioned it many times. So for this one is not the definition of ionic bond. Now, even though you list it into the book, and I must say to all of you that that may lead to some misunderstanding or alternative conception for the students who first time learn what is meant by ionic bond. Now, why would that sentence come up with it? It comes with the concept of drawing the ionic, the electron diagram like this. Okay, so they would show the two types of atom, metal or non-metal. The electrons will be going through like this way, and then you write such. So ionic bond. Now, it is somewhat theoretical. Now, the actual case is that we would have an array, 3D arrays of the cations and anions alternatively placed. So, you will see a net electrostatic attraction between plus ions and negative ions. So we call that ionic bond. Now, this is what you have to highly aware of. Okay, do not just copy those wordings in the textbook and treat it as a definition. Now, this is not. You have to stick back to, first of all, the electrostatic force between something, between positive and negative. Now, similar case is on the second one. Now, this one, this will be, it has been asked for many times in past year, no matter on drawing the diagram, asking for definition, or maybe even in the MC, they ask you to choose the correct definition. 好，有問答，但每人都要答一次啊！用中文好、英文都好都得，一定要搞清楚啲嘢。有冇？陳景熙先啦。Metallic bond is an attractive force between nucleus and delocalized electrons. Not nucleus, but positive metal cation ion. So what is that? What is that? What is that definition? Now it is we'll call it metal ion. But I have also seen this definition before, but it's not metallic bond. What is that? Between nucleus and delocalized electrons. We have got another attraction. Do you know what's that? We call that nuclear attraction or nuclear charge. Okay, nuclear attraction. So it is a attraction force within the atom. But for the metallic bond, it is an electrostatic force between metal ions and the localized electrons. The way to define is different. Okay, so be aware of that, the difference in the definition of the two. Yeah, the similar case on covalent bond. 陳記希唔識講嘢咧，開始。龐家浩咁遲戰歌講完。Covalent bond.龐家浩 are you here?點睇呢個 Covalent bond. A covalent bond is formed when one or more pairs of orthogonal shared electrons they are shared between two atoms. Sharing outermost shell electrons between. What is mean by sharing outermost shell electrons between non-metal atoms? 咩意思啊？ So what is the definition? Yeah, so it is the bonding electrons, okay? Again, it is the electrostatic attraction or electrostatic force of attraction between shared electrons. So you know that is bond pair and positive nuclei of the two bonded atoms. Okay, so this is the definition of covalent bond. So be aware of it. And next, I will call upon some 40 students to help. 陳龍喎, a compound made up of metal and non-metal is ionic compound, while that of made up of non-metal only is covalent compound.
That's not true, because there could be polyatomic ions that are completely non-metal.
That's what category is it? Is it ionic compound or covalent bond? What do you mean? Ionic compound.
Within the ion itself, it would be a covalent, ion. It would be covalent bonds, but the entire thing itself would be an ionic compound. So, for example,
any concrete examples?
For example, ammonium nitrate.
Ammonium
nitrate. Yeah.
Nitrate. So we have got the cation and anion found inside, while those they are made up of nonmetals. Okay, it is what we call it as an exception case. Okay, exception. So ammonium nitrate. So inside that we would have ionic bond between the ions. Okay, ionic bond between the ions. But we would have the covalent bond between the atoms within the ion. No matter this cation or anion. So what we call it is the polyatomic ion, right? But not for simple ion. For polyatomic ion, we will have such. And this is the first statement. A compound made up of metal, non-metal is ionic compound. It's generally true, but we can think of exception. How about the next sentence? Made up of non-metal only is covalent compound. Yeah, so somebody say not true. Again, you will give some exception. SiO2. So you mean for covalent compound, you can also link up as a semi-metal with non-metal. Do you mean like this? What else? What else? Any other any other examples? Counter examples. NaCl. NaCl. Yeah, NaCl is example fulfills the first sentence. Okay, but for first sentence, it's not universally true for whatever you pick up any ionic compound, it must be containing metal and non-metal only. Yeah, first of all, somebody would say it's as AlCl3, a very strange example. Okay, a very strange example. Why? Aluminium chloride, beryllium chloride, it is what we call it as covalent compound. But a little bit out of the syllabus, right? For barium chloride it is, but aluminum chloride is a little bit out of the syllabus. While you may find a aluminum chloride and beryllium chloride. Why is it like that? Because of the high charge density of chloride ion. If you want to think it like this way, for chloride ion, those electron cloud is a little bit larger, while it is more diffused. Okay, more diffused electron cloud. So what is the hidden message? It can be easily distorted by the surrounding environment, just like positive charge. If that is the case, this one, the charge of it, the electron cloud will be much distorted towards the aluminum ion, so as to having some electron cloud density in between. Okay, in between the chlorine, aluminum ion and chloride ion, and make it as a covalent bond, and it is a covalent bond. Okay, so we may find a covalent bond instead of ionic bond. Now, because it's more like a sharing of electrons. Similar case that you may find it is on beryllium. Beryllium ion is too small, very, very small, but high charge. So it will also lead to a similar phenomenon. right, of distorting the electron cloud of a chloride ion nearby to make the bond like more like a covalent bond. So we will say that to a very strange example having a covalent compound. Okay, so it is somewhat you talk about the polarizing power of this metal part, high polarizing power. And at the same time, we've got described the chloride ion of having a high polarizability. Now, I know that it is out of the syllabus here, right? But just let you know, we have got some of the strange examples here. And okay, can you get my point? So somebody has suggested using MnO4 minus dichromic ions, the covalent compound, but involve metal and non-metal. Yep, but what is mean by covalent compound? Now, but KMnO4, now this is the whole chemical. You describe it. So inside we have got positive and negative ion. So it is also, or we call it as a covalent compound. But the permanganate ion itself is not a ionic compound. It's just a polyatomic ion. And in between the manganese atom and oxygen atom, they are bonded by covalent bond. Okay, is that clear? Now, let's take a look on the second case. It is this one, covalent bond, dative covalent bond. Can you make a difference between two? 燒盡氣
dative covalent bond 係，我而家寫唔到，type 唔到，所以要用口講。dative covalent bond 係一個
咩啊 ？OK 喎，順便 disconnect 喎，啱啱好喎，真係講下冇聲嘅，應該係早晨啊，時間係12:21啊。
阿 Sir，咁我咪繼續講啊？定係你聽唔到？
你繼續啦，我唔
OK，
我講完㗎啦。佢對於我嚟講冇乜意義啊。你意義大啲而家。
Dative covalent bond 係一個有lone pair electron 嘅 atom， 然後佢就 contribute 咗，佢就 contribute 咗佢呢一個 lone pair 俾一個 electron deficient 嘅 atom 去做一個 bonding pair。whereas 呢個 covalent bond 就係一個 sharing of electron， 即係兩邊都 contribute electron 出嚟去 form 一個 bonding pair。而 dative covalent bond 就係一個即係有一個好多 electron 嘅 atom 去將佢嗰個 lone pair electron contribute 做 bonding pair。
All right, so any example? Give me some example of covalent bond, dative covalent bond.
Covalent bond。
I believe the hydronium ion, the HEO ion would be one of them. For examples for
aluminium what? AlAH4 you mean?
I think
ammonium, hydronium,
yeah.
hydronium, H3O plus, H3O plus, ammonium ion. Okay, and also we have got ammonia boron trifluoride adduct, right? So many different examples. Inside that, we can see both dative covalent bond and covalent bond. So I just pick up one of them as example, and you can get what I mean. So it's water with that structure. So we have got two lone pair electrons. So once it meets the hydrogen ions, in which no electrons are found, so we have got a dative covalent bond, right? Having the sharing of electrons contributed by the same atom. Okay, so for oxygen, atom, we have got one lone pair electrons. That lone pair electrons contributed as a bond pair. to make a covalent bond with the hydrogen ion. So that's why we would have the two terms, which is electron-rich and electron-deficient center. So for oxygen here, we've got lone pair electron, so we have got the electron-rich center, while for this part, it is electron-deficient. Now, after the formation of covalent bond, we may see the hydrogen ion to attain greater stability. Okay. And this is what we call it as a dative covalent bond. Now remember, the bonding electrons, they are contributed by the only one atom. But for the covalent bond, the bonding electrons, they are evenly shared between the two bonded atoms. So that is the difference. Okay, similar case that you may think of as ammonium ion is correct, the adduct is correct. Okay, and also carbon monoxide. Now you may think of so many examples of this. Okay, go home and try to make a clear difference between the two. Okay, and the next one, all ionic compounds, they are soluble in water. 陳浩熙
PBCl 唔係 soluble。
PBCl 咩嚟㗎？
唔係 PBCl2 啊。
PBCl2. Okay, PBCl2, yeah. The answer should be take a closer look at the word not ionic, not all ionic compound, they are soluble in water. So you may think of so many exceptions. Okay. Yep, calcium carbonate, so many. So ionic compounds conduct electricity. 張家榮. Yep, barium sulfate is also correct, is an exception. 張家榮. Yes 咩啫？你都遲起身啦。But in solid state, no. I'm about to answer. Yeah. 快啲啦。So the key point is where ionic compound conduct electricity. Mobile ions. First of all, try to make a comment on this sentence. So you should give some condition here. Ionic compound conducts electricity. Here, right? So you need to give some conditions. At all states, the answer is not correct. Okay, so yeah, only in molten state. Correct?
It also applies if it's in an aqueous solution.
Yeah, so you are going to write in the aqueous solution also, in molten state or in aqueous solution. Then in under that two states, would it produce what we call it as mobile ions? Okay, so you see the word or here, or in aqueous solution. So to get rid of the fact, the consideration of whether or not it is water soluble. So only with that two states will have a chance of mobile ions, transformation of mobile ions. Okay. And what's next? Magula. CO2 and SiO2 adopt similar bonding structure. Magula. Magula, are you here? Magula. Thinking. Now put a star here. This sentence, right? This one is frequently asked, right? That type of similar argument. in which you know there is something wrong. What's wrong with it? Carbon
dioxide is a discrete, the discrete molecule, and silicon dioxide has a giant covalent structure.
Okay, discrete molecules, which means it adopts a simple molecular structure. Simple molecular structure in which we have got discrete molecules. SiO2, giant covalent structure. So if you want to talk about the bonding between the atoms, they are the same, which is the covalent bond between atoms. But structure, they are different. Okay, the structure, they are different. One of them adopt a simple molecular structure. The other one, SiO2, is giant covalent structure. Even though you talk about both are the same as group 4 oxides. Okay, so this is different. So Mayalam, could you please circle it and mark it? And the second sentence, the next sentence, 128. In graphite, each carbon atom uses 3 outermost shell electrons in forming covalent bond. The remaining electron is delocalized between layers of carbon atoms.
Okay, in forming single bond with another, in forming single bond with each of 3 carbon, each with
You want to neighboring carbon atoms, okay, to form the 3 single covalent bond, you mean?
Yes, yes.
What else?
And the remaining electron is, moves along the layer.
Yeah, the word is not between, okay? It's along. It's within the layers, okay? Along the layers. Along the what layers of carbon atom, what is that? It is in terms of a hexagonal planar structure. So what is that? We call it as graphene. Okay, it's a graphene. So along the layer, but not jumping from layer to layer. So it's different. Okay. So metals have high density. Correct for all. Not all metal. Could you please give me some counter examples? Lithium does not. What else? So mainly group 1 elements. It is an exception. Okay. So if you see the word high density, generally speaking, it is described as the transition metals. It's usually referred to transition metals in the past because the transition metals, they are treated as a commonly used metal. So we try to make a generalization based on those commonly used metals. So we will usually use that term high density to overgeneralize the whole thing. But indeed, you will want to talk about group 1 and also some group 2 elements. They are generally having low density when you compare with those of transition metals. But of course, if you use density of water as a reference point, you can tell the group 1 elements, just like lithium, sodium, potassium. They will float in water, on water, so you tell it is have a low density. Okay, but if you want to, at the same time, use group 2 elements to compare against transition metals, you may also do some similar comparison that group 2 elements also doesn't have a very high density at all. Now, even though it sinks in water. Can you get a point? So this is what I would like to draw attention to. The word high density, or you generalize the whole thing, metal have high melting point and boiling point, usually refers to transition metal. But if you want to take a look at the periodic table, you check it group by group, you may find some other special cases. So indeed, it's not just so many special cases that overwhelms the whole thing, but that sentence is overgeneralized. Can you get the point? It's overgeneralized. And the second sentence, 何展鵬, all substances with giant covalent structures are hot. Not hot. You mean all substances with giant covalent structures are not hot? You mean all substances with giant covalent structure are not hot? 係咪咁意思啊？ Don't bully him, miss. Please, it's a matter of English. You mean that not all substances with giant covalent structures are hot? Do you know the difference? If you put a not here, right, in different position, it gives different meaning. Okay, now, okay, so you should know not all. What he means is not all. Exception is graphite. Between the graphene layers, there are intermolecular forces. Okay, so it is rather weak. So we will say in the macroscopic viewpoint is somewhat slippery. Okay, it's somewhat slippery. So the way to change it is not all, but not put a not here. Okay, it gives a different meaning. Remember, if put a not at the beginning or near the end, it gives different meaning. Do you understand? Something about English. 初中上. During melting and boiling of substances with simple molecular structures, all the covalent bond or intermolecular force are to be overcome. Now, of course, it is you go back to the to case by case consideration of that term. First of all, melting. During melting or of the substances with simple molecular structures. So, how will you modify the whole thing? Cho Jong-sung, are you here? Yep. Tell me how to change this. It's conditional. We have got two sentences. Yeah. How to modify the thing? Some problem about the Zoom again? No. You may try to speak. Instead of using WhatsApp, you may use the Zoom to test whether or not you have got connection. You mean you lost connection? What is I am fine? but the connection to me is no good. You're not connected to chemistry. Okay, anyone who can help? 陳景希。陳景希。
係啊。
哦，陳好希博咗出嚟添，咁點啊？
哦，唔係啊，例如係水咯，嗰個exception。
咩？例如係水？咩啊？即係點啊？唔明喎。你想講咩？
唔係啦。
咩嘢唔係啊，大佬？邊句啊，大佬？
即係
邊隻字錯啊？
唔係 to be overcome 啊。
咩啊？
佢就係會 overcome 嗰啲 intermolecular force，但係唔會 overcome 啲 covalent bond between 嗰啲 atoms 啊。
overcome covalent bond 唔會係咪啊？
係啦。
即係 covalent bond 唔使係咪？
係啦。
咁 intermolecular force 就 to be overcome 就啱嘅啦。melting 好 boiling 都好，都係咁寫啊。
係啊，係啊。
係啊，咁啊係錯啦。潘樂之點改啊？
啱啱講咩我聽到？
點改啊？呢句説話？
係啊，during melting or boiling, with simple molecular structures, only the intermolecular forces will be overcome.
Intermolecular force 你又聽唔到啦。
聽到。
係即係咩啊？側邊隻字啊？
淨係 intermolecular force 係需要被 overcome 其他。
係咁呢句説話，淨係炒 covalent bond 要 intermolecular force 就得啦，係咪啊？咁就錯咯。錯咗啲咩？有冇人見到 between molecules？冇問題啊，寫唔寫？係啦，
唔係 all，
唔係 all 啊 ，all 呢隻字啊 ，OK，all 呢隻字出咗事啊。So intermolecular force, which means that between the molecules already. But of course, or is the key. Melting is not all intermolecular force will be overcome. Just part of that. For boiling, two cases, okay? Just part of that. For boiling, almost all, but not all. Do you know why? Otherwise, if you want to talk about the connection between chlorine gas, for example, there are also have the intermolecular force in between. So if you just overcome all intermolecular force between the molecules, what is the hidden message? Okay, you are pulling, you are making that two molecules separately into infinite distance, right? So this is not the case. So many of the if you see the word or, you should be very careful. Now we stick back to two cases, melting and boiling. OK， 好，最後啦，去到 microwave two 啦 ，microwave two。咁啊，有冇人答到我呢幾個嘅分別咧？又係你啊，張家榮。Trigonal planar, trigonal pyramidal, tetrahedral, trigonal bipyramidal, four of them. What is the difference? 全部都有 T 字頭啦，有 trigonal 啦。So what is the difference between them? 好，咁有咩分別啊？喂 ，difference 啊嘛，呢4個有咩分別啊？哦，跟住又扮接收唔到嗰啲係咪？Some of them they are symmetrical, while some of them are not. Hybridization is the presence of lone pair. Now, first of all, it depends on different of giving answer of different tiers. Tier number 1, the most fundamental one is about the shape. The shape is different, okay? So therefore, they represent different shapes. And second, if you want to talk about the electron centers, or you want to talk about the electron pairs, we adopt whisper theory, whisper theory, and you would it is somewhat related to this.
哇！入到嚟展上
Okay.
好感動啊！
It is to make sure that there is a minimum repulsion between the electron pairs. So it is somewhat related to the number of electron centers. Of course, for these cases, is out of the syllabus for the time being. You talk about hybridization is another thing, okay, another tier. Okay, so if you want to go back to DSE, it is related to the number of electron centers, and this includes both the bond pair, number of bond pairs, and number of lone pairs. If you want to talk about. Okay, so the shape of these is different. Take a look on trigonal planar. We have got what? How many electron centers are there? We have got three electron centers for trigonal planar and 3 bond pair. Trigonal bipyramidal, we will have what? 3 bond pair, 1 lone pair. So we may find some examples, right? Just like what Pong Gao has been suggested, good is BF3 for trigonal planar, NH3 or for ammonia tetrahedral, SiH4, you may find 4 bond pair, no lone pairs, and about PF5. PF5, we will have 5 bond pair. Okay, it is different. Number 2, Susan, hey, in order to celebrate that you can come in, shall you answer this one?
係
All substances obey octet rule.
not all substances obey octet rule 咯。
係有冇 example 啊？
period 3嘅 element 佢哋都唔係佢哋基本上 form 嘅。
咩 two group 啊
period 3嘅 element 好多都係唔 obey octet rule 嘅。
OK，
譬如 PCl5 咁樣。
Some period 3
Some period 3
substances, right? You mean? Or period 3 compound, you mean? Okay, just like what? PCl5,
Yes.
PF5, etc., right?
Yes.
Okay, and what else? What else? Less than octet, 有冇㗎？
BCl3.
Yep, BCl3. So you may find it is less than octet. So period 3 and period 2 compound, it is related to the number of the electrons that can be accommodated in the outermost shell. It is related to this, okay? Nitrate, ion, you mean? Nitrate ion. Not obey octet? How? Helium, of course not. How about nitrate? Can you draw the structure of nitrate ion? and then dative covalent bond for N and O, and then O minus. Okay, which one is said not to be octet? You mean nitrogen? Nitrogen is also octet. Is it? Nitrogen. It's also octet. Okay, but if you want to talk about NO or NO2, take a look on these two cases. NO, NO2. It's not octet. Carbon monoxide is an octet. Take a look, carbon monoxide. And we have got dative covalent bond between C and O for 陳景熙. From where to where? Okay, just count it again. Is it octet? Octet for O. Okay. How about carbon? Still octet, right? So 講 octet 嘅話就呢啲係啦，唔係 octet 就呢兩個唔係啦。And for the remaining 5 sentences before we end up the lecture today, electronegativity 又嚟啦。Electronegativity 鄭群威 definition of electronegativity. Represent the power of an atom or element to attract electrons in what electrons? In a covalent bond, yeah. So which means the bonding electrons. Okay, the bonding electrons. We talk about power of the of that element in the bonding, in which to pulling the bonding electrons towards itself. The power of the nucleus. 又同我講陳景熙話 nucleus 啱啱。係講佢講緊原子核啊，啱唔啱㗎？The definition is a measure of the tendency of an atom, not nucleus, to attract the bonding pair of electrons towards itself in a covalent bond. Okay, so 呢個又要背啦，唔該。每隔幾年問一次定義，每隔幾年啊？啊，唔係呢個。So this is what I would like to remind all of you. 第二個 polarity of bond, polarity of molecule 出現咗呢啲字眼啦，咩嚟嘅咧？又有個例子啊，而家你唔識解下邊嗰句啦。In PCl5, the polar PCl bond cancel out each other, so the PCl5 molecule is non-polar. 錯咗咩？
呢個應該係講緊individual dipole moment of PCl 嘅 bond 嘅 polar bond 咯，係講。
The dipole moment of PCl bond cancel out. So if you don't understand about the concept of dipole moment, you may use the word polarity to describe this one. The polarity of the polar PCl bond cancel out each other. Okay, so we would not say the bond cancel each other. Okay, so this is what you talk about polarity of bond. But the polarity of molecule, you just talk about the net dipole moment of the molecule. Or you want to tell it is a net overall polarity of the bond. Okay, so this is what I would like to remind you. Now remember about the wordings. 小心有陣時係自己製造寫錯啲 wordings 㗎，呢個你要小心啲啊。好，呢個 cert level 成日問嘅 cert level marking scheme 成日出現嘅呢個 term， 知唔知錯咗喺邊 ？cert level marking 知唔知錯喺邊啊？唐家豪啊！唐家豪唔見咗啦，又 let me see 掛咗喺邊啊？好，林家齊。Marcus，呢個
Let me type first, because first it doesn't depend only on molecular mass. The shape of the molecule will also be taken into account. So if you have two molecules of the same molecular mass.
Is it depending? You mean the molecular mass is just one of the factor that affect the strength in the molecular force? Agree? 係咪啊？好啦，潘樂之查到花晒啦，好似唔係喎，係咪啊？你講嘅呢句係，但係要評價呢個説話個錯嘅位喺邊咧？就 mass 嘅字 ，mass 係錯 ，mass 係錯啊？點解咧？ Now try to take a look on the nature of the intermolecular force. What is that? No matter it's dispersion or dipole, you are talking about what? You're talking about the attraction force. Okay, between positive and negative one, and in particular, if you want to talk about the dispersion force, okay, dispersion force, you are talking about the size of electron cloud, right, to be distorted. So it is somewhat related to the size of molecule. Okay, it is something related to the size of molecule. But of course, the shape of molecule, would it also affect the strength of intermolecular force? The shape of molecule. Maybe you have heard of some cases just like this trans, right? And it is somewhat related to the shape of molecule. 做冇啊？Now, shape of molecule to contribute more on changing is affecting on this melting point, because the shape of molecule related to packing, and which it will affect the melting point. Okay, 做冇啊？
apart from that, the dipole moment of the molecule also matters.
Or polarity of molecule, you mean? Polarity
Yes.
of molecule. So this will affect the strength of the dipole-dipole attraction. So you know dipole-dipole attraction, it is also one of the subparts, right, which contributes to the intermolecular force, the change in strength of intermolecular force. So it's not just the molecular size or the size of electron cloud, it will affect the intermolecular force. You have to think of the polarity as well. Okay, so point number one, molecular size. Point number two, polarity of molecules. Okay, and shape of molecule, does it affect? Also yes. Okay, and it is more significant when you talk about melting point in terms of packing of molecules. The last one, the definition of hydrogen bond and its condition of formation. 有冇人記得？背咗未啊？呢個 hydrogen atom is formed between and hydrogen bond 又係背嘢啊，唔該。Put a star here. Is what you have to memorize. Is formed between the hydrogen atom attached to electronegative atom, nitrogen, oxygen, fluorine atom, and the lone pair electrons and another electronegative atom. Yes, correct. Okay, correct. So the definition. So its conditional formation will, as said before, we have got two conditions. One is the hydrogen atom directly attached to highly electronegative elements, just like NOF, okay, atom of high electronegative element. And second is we've got lone pair electrons on the highly electronegative or atom of highly electronegative elements. Okay, so we have got such that we may form a highly polar bond. Highly polar bond, we call that hydrogen bond. So it is somewhat like this. So we may have got O here, HH, we've got lone pair, and we've got minus here, and we've got plus. While you talk about hydrogen bonds, is in between. Something like this, okay? Is that clear? Now in this lesson, we come over review on Michael 1 and Michael 2. So I would like to have a summary of those. You may find that why is it so difficult and to comprehend is because of the sub-microscopic point we are going to have. You are now dealing with somewhat we cannot see. So it adds a certain level of difficulty. Second, be aware of not to overgeneralize the whole thing. So we may see some words just like or, must, something like that, and this may affect our judgment of the answers. Now, only the term addition of the word or will make the whole sentence become incorrect. So you have to think of so many other cases. Just what I mean is the exception to further elaborate that statement, whether or not to what extent is correct or under what situation is correct. The third item is too brief. For example, a ionic compound conducts electricity. This one is overgeneralized. So you have to make some conditions to make it true again. Ionic compound conduct electricity and in molten state or in aqueous solution. Is that clear? So this is what I would like to talk to you about this. Well before the end of 2020, we have got some more to go about the confusing terms of confusing items. you know that you have to get yourself prepared well for the coming mock exam. Okay, the first to start with is external mock exam. Now, something I need to to tell all of you is I after thorough discussion with Ms. Yip from biology, we decided to give way by scheduling the chemistry mock exam to 30th of December, which is chemistry, while for 28th, which is biology. Okay. So for the details, I would like to post it onto your WhatsApp. I need to give way. Otherwise, quite a number of you cannot manage to do both paper at the same time.
I'm okay with any.
Okay.
I'll just make it like come out first, okay, and then you can choose whenever you want, okay?
Oh, it doesn't matter.
Clear up the
It's time
table.
to enjoy
once it was
lunch.
ending.
Okay. Bye bye.